Hi, Ina. Good morning. Okay, are you all ready to get started? Yeah? Okay, today we're going to be talking about while loops. So, agenda, we will do a recap on logical operators, go into while loops, do some practice with building more of Wordle so we can put all these pieces together later at the end. Okay, recap. So logical operators, what are they? They're operators that we use to combine booleans into these expressions so that it evaluates to one single boolean at the end. So we will use these often when we're writing if statements, and today we'll be using them in our while loops too. So remember, they just combine booleans. So and is an operator that returns true if both of the operands that you and together that you combine with and return or are true. And or will return true if either of those operands or even both of those are true. So you or to something together, you or them. If one of them is true, then or will be true. Okay, not, it will just invert that value. So if you have not some value, not true is false, not false is true, it just inverts the value of the operand. So that one's pretty self-explanatory. Remember, when we have expressions with a bunch of different logical operators in them, we have to evaluate them in some order. So like we have PEMDAS with arithmetic operations, we have the PNOW or now or whatever order of operations. So we start with whatever's in the parentheses, then we'll do whatever's knotted and negated first, and then whatever's anded, and then or together. Yeah? So why are they important? Well, like I said, we use them in our conditions. So we can make our conditions more complicated and give our computer program more flows to be able to make decisions and do different behaviors depending on different things or different values or different data or whatever. Okay, let's practice. So I have my price, a variable that stores the value 75. What does this evaluate to? Hi, Prashash, come on in. So we have not, and then price is greater than or equal to 50. So is this true or false? I hear false. I see some faces that you're all thinking. So what I do is I evaluate this price is greater than or equal to 50, and I say 75 is greater than or equal to 50, so that is true. So not true is false. Make sense? Yeah, Azil?
So like the logical operator, the math stuff, the comparison stuff.
Yeah, the comparison operator, right?
Yeah, the comparison operator
Yeah.
is like as person, it has it's prioritized over.
Yeah, great question. So for the not, the operand, the value that you do that logical operator on has to be a Boolean, right? So then it looks like we have this comparison operator that also gives us this Boolean. So we do that first. We do that arithmetic first, and then we go from there and then do those logical operators. Yeah. What about this example? So we want to do the arithmetic first. False? True? I see you're all thinking. So we do price is equal to 70. We check that, right? The double equals means we're checking equality. That's false. Or, and then let's check this one. Let's evaluate this one first so that we get two Booleans on both sides. So we have price is equal to 75. That's true. So we have false or true. So that'll give us true. So remember, these logical operators will take in values that are Booleans. So we need to do these arithmetic operators, these comparison operators first, to get us those Boolean values to then combine those logical operators. So exactly what Zeal was asking. Okay, what about this one? False, right? If you kind of read the English, it's like, is price greater than 20 and less than 40? That doesn't really make sense to me if we're using the same price variable, so false. Kind of like look at this in English too, to like not confuse yourself. So does price not equal to 50 and it's less than, and not less than 70 or 60? True, right? Okay, what about this one? So parentheses goes first.
True.
I hear true. Okay, so price greater than 10, yeah. And it's less than 70, yeah, that's true. So true or, doesn't even matter what that is because we have true on this side. It equals true. Any questions? So this is a great example of where we're combining a bunch of operators, right, in our expressions. Totally a very common thing, very valid thing that we will do oftentimes when we're writing if statements or, like you'll see today, conditions and while loops. Okay, let's take a look at this code, and I want you all to tell me what's wrong with it. Find the bug. So there is something wrong with it, and I want you all to try to figure out what it is. And I'll give you a few minutes to think about it together. Do you already know, Jola? You don't say it. Huh?
It's similar to the assignment you gave. So,
Yeah. I'll give you a few minutes. Few minutes first. maybe you already all saw this on some lab or homework or something. But if you didn't, try to use your brain. Be like, okay, if I was a computer, how am I processing this, and what is the bug, or what is a little bit wrong? Why is it not doing what we're intending it to do? I see you all looking at the screen. You all can talk to each other too. But I'll give you a few minutes just to think about it. Pretend like you're a computer. Hi, Donovan. Good morning.
Is there a variable for each of these strings?
Yeah. Okay, keep thinking though. Keep thinking if you haven't thought of it. Still thinking? You know it, Pasha? Yeah? You all good? Who wants more time to think about it? You're all good? Okay. Let's try it, right? So, oh my gosh, this was me testing it earlier. Okay, so let's run it. I think it's taking a while to boot up. Okay, so I expect it. Is this big enough, by the way? Okay, I expect this to be true, right? Or it'll tell me correct, yeah? And then if I did capital Nashville, also correct, yeah? Let's make sure I test the edge case of it being incorrect. Let's say I think it's in Ohio. Oh, well, it looks like it told me correct, right? That doesn't seem right. Let me try another one. Seattle. Oh, it's still correct, right? Who can explain to me why that's happening? Okay, Joel, I already know. Manoj, I see you. Anyone else have thoughts? Daniel? Prashant, this is what you were saying, right? Yeah? Do you want to tell me why it's always telling me correct? Why do you think? Just think out loud.
So for me, the program looked it was error in the program because the variable answer needs to be assigned to different strings.
Yeah.
Rather than one variable for two strings.
Yeah. Exactly. So it looks like I'm checking if answer is this or it's this string. So the computer is going to see this condition and say, oh, my OR needs two different Boolean values on either side. It evaluates this and it says, okay, if my answer is equal to lowercase Nashville, or it's this string. And strings evaluate to what?
True.
If it's a string that has characters in it, it evaluates to true, right? So if we did let's do it up here. Boolean of Nashville. And I print this. That gives me true. Remember, the only time you get false is if you have the empty string. So that means this always evaluates to true. Doesn't matter what my input was here. I would get correct every time, no matter what, because this evaluated to true. So just be careful when that happens. So if we go back to the slides, we'll go over it again. So when we have this line of code here, the if statement, in that condition, this gets evaluated first, and then it evaluates this. But remember, Python considers empty strings to be false and all other strings that have some sort of character in it to be true. So then this is some condition, or with a condition that's always true, then this will always be true. It'll always go into this if statement and give me correct, no matter what input I gave it. Make sense? So how do we fix it? We have to check that answer is equal to capitalized Nashville as well, explicitly. So we have answer equals lowercase Nashville, or answer equals uppercase Nashville. Yeah? Another way that you could do this, sorry, I'm switching tabs here, is I could say, actually let me think. Okay, no. Okay, wait, actually let me try this. I don't even know anymore. I was just thinking that maybe you could do this. Do we think this would work? I don't even know. Okay, let's try this, because it's saying that or that. Let me try it. Yeah? Okay, yeah. Does this print? Oh, no. Okay, so you have to do the separate checks, because I think it evaluates this, and then it says this or this. This will always be true, but then answer is equal to... Yeah, just do it the other way. I just wanted to check and see if that would work. Yeah. So then we have answer is like this. Then it should work as I expect it to. Then if I type in like Seattle, now it gives me incorrect. Because now it's checking that answer is not one of those. Seattle is not one of those answers. Okay. Does this make sense? Okay, any questions? No? Okay. Should we talk about while loops? Okay. So let's say I had a computer program that was checking if a user inputted the correct password. So let's say in my case, the password is the string hello world. So I take in my input, which is the user typing in what the password is, and the output is something telling me in the console that either access was granted or I got the wrong password. So access will be granted only if the user input equals, in our case, hello world. That's what we're saying the password is. So if you think about that logic, it makes sense to write an if statement, right? If the user types in the right password, then I grant them access. Else, I tell them it's a wrong password. So this is what that if statement looks like, right? I have my password and I'm storing in that variable the input to what they're telling me they think the password is. So if password equals hello world, then I would tell them access is granted, else I put wrong password. This all makes sense, right? So what's wrong with this? Well, if I tell them this and I run this code, it only runs once, meaning that they only get one try to really give me that right password. So what we can do is we can take this block of code and then try to figure out a way to run it multiple times, because we want to keep asking the user for the password until they get it right. So we keep asking for a new input and then keep checking it until the user gets it right. So we're trying to like loop through this, right? We want to run this block of code repeatedly multiple times without like copying this loop over and over again, right? We don't want to copy this again and say give them 5 tries and then copy this if statement 5 times, right? Like that doesn't really make sense. It's really duplicated code. We don't like that. It's not readable. So let's try to reuse the code we already have. So we can take this block and then we can put this inside of a while loop. So you can see we have this while condition, kind of looks like an if statement condition, and then put this same block of code in. We'll go over it more later too. So while the password is incorrect, then we keep asking for this input, right? We keep asking for the password. And just keep in mind, we have to have this initial value initialized before this while loop. We have to declare this variable before the while loop because we're referencing it here. If we reference this password and it doesn't exist, what's going to happen? Yeah, it's gonna say, I don't know what that is. It's not defined. You haven't even initialized it or declared it yet. So just keep in mind that when you have a while loop, you're going to have some sort of variable that you check with this condition that needs to be initialized beforehand. We'll go through more examples, don't worry. Okay, so just to maybe try to make this distinction between if and while, let's look at some examples. So if the lights are on, then shout lights. So because the lights are on, I would shout lights, but it would happen one time, right? Let's say I change the if to while. So while the lights are on, shout lights. So I will keep shouting lights until the lights turn off, right? And then I'll stop. Okay, if you've clapped your hands less than 5 times, clap your hands. So when this happens, I'll see my code and I'll see, okay, the condition is if you've clapped your hands less than 5 times, then I would just keep clapping, right? There's nothing telling me to stop because that code would run and I would just go into this case where it says clap your hands and I'm just there until I'm told otherwise in the program maybe. While you've clapped your hands less than 5 times, clap your hands. So that means I clap and I count and then I've still less than 5 and then I hit 5 and then I'm no longer in this condition, so then I stop. So there's actually an explicit thing telling me to stop. This condition is telling me to stop at 5. Okay, if you like tacos, give me a thumbs up. I see Vivian doing it. Yeah, so that's great. You one time, give me a thumbs up, that's good. So while you like tacos, give me a thumbs up. If you like tacos, then I would just see your thumbs up until one day you decide you didn't like tacos anymore. And you would just be walking around like this, right? So in some cases, maybe it makes more sense to use an if, maybe it makes more sense to use a while. But you can kind of see like the differences already in these examples, right? Yeah? Okay, so while loops. They're a control structure that runs a block of code repeatedly until a condition is no longer met. So in general, it's while some condition is true, then do something. So once that condition becomes false, you exit that loop. You go out of that part and then keep going with the rest of the program, right? So you can see in this diagram, while some condition is true, you keep looping. You keep doing that code repeatedly. And then once that condition becomes false, you just keep doing whatever is specified after that loop. Okay, let's talk about the syntax. So line by line, if I was a computer reading this code, I would see, okay, while I have this keyword that's telling me Python is trying to start this while loop. So it's a keyword in Python, don't forget that. Just like if statements, if, else, elif. And then again, you have this condition. And remember, for while loops, this condition needs to evaluate to true for something to run. Versus if statements are like true or false, do something based on that. So while, again, some condition that should evaluate to true at some point for you to do this code that you're telling it to. And then end that with a colon. So again, you're telling the computer that the condition's done. You're gonna start this code block that will run when this condition is true. Okay, questions on this? Make sense? Okay, so this expression needs to evaluate to true in order to run and do stuff, whatever, that's indented under this while loop. So again, indentation is really important too. But keep in mind, it also needs to be able to evaluate to false to then exit this loop. Because otherwise you'll just be stuck in this loop repeatedly. And then we'll see an example of that. But then you're just stuck. And then your computer program is just stuck too. Okay. So in this example, what happens? So I see my count is equal to 3. And while count is greater than 0, I will do something. And then after that loop, I will do something else. I'll print blast off. So my count is 3. It's greater than 0. So I go into the while loop. And then I run that code inside there. So print count. So I think I'll print 3, right? And then it looks like I'm updating count to be 1 less than what it was. So now my count is 2. And then what do? I go back to the top and see if that condition is still true. So if that condition is still true, if count is greater than 0, my count is now 2, so 2 is greater than 0. I go into the while loop again, right? Print 2, count is now, what, 1? Yeah? Go back up to the while loop and check that condition. If it's still true, it is still true, 1 is greater than 0. Do that same process, now count is 0, right? Go up to the while loop, now 0 greater than 0. That now evaluates to false, right? So then I exit the while loop, exit that statement, and then print blast stuff at the end. So if you see it in code, oh, I forgot to test this with y'all. Okay, well, let's test it now. Okay, so remember my password program. I had hello world. This should give me true, right? Or access granted, right? And then anything else should give me wrong password. And then I'll keep checking and see. Okay, let's go to this one first. Sorry, I'm distracting y'all. Hold on. Okay, while loop. So I run this and I should see 3, 2, 1 blast off, right? I go 3, subtract 1 from count, then it becomes 2. Keep looping until 0 is not greater than 0, and then I print blast off. Okay, let's go back to this one. So I keep typing my password right, and it keeps asking for my input in the same way we just saw that while loop until I finally type hello world. Access granted, and it no longer is asking for my input because I've exited that while loop. Yeah, so now I'm here once this has reached this point. Okay, questions? Nothing? Okay. So, what about this one? What do you think will happen? And what is maybe wrong with this code?
X will be forever less than 2, so it will keep running.
Yeah. So, yeah, I see some of you getting it. So, x is 1. While x is less than 2, I'll print test. So, 1 is less than 2. I go into here, and it looks like I'll print test. And then I'll go back to the top of the while loop and check that condition again, right? And then what is the value of x? It's 1. 1 is less than 2. I go in here. I print test. Then I go back and check if this condition is still true. And it looks like it's still true. So it will stay in this while loop forever. And then will this, oh my gosh. Will this ever get there? Will this ever print? No. Why? Yeah, it keeps looping and checking this condition, and it'll never exit that loop because this is always true. So how should we fix it? Change x, increment x. Yeah, exactly. We need to update this variable such that this condition evaluates to false. So if you're not updating this variable that's being checked in this condition ever in the while loop, then you know something's wrong and you're probably going to have some sort of infinite loop. So if we take a look at it, let's try this. So what happens when you see it? It just runs forever. Yeah, do you see my scroll bar just getting smaller over here? So the only way to quit out of the program then is to just stop it. Oh my gosh, it's getting so long because I waited too long. No, just kidding. Okay, yeah. Yeah, see, it just keeps going. I don't even know how to get back up there. Okay, here. And then you have to like Control C, right? Or Command C, whatever, and then stop it. Okay. So we have to update X. Let's just update it now. Okay, so what can we do? X is equal to what? Yeah, we could do x plus 1. We usually will increment by 1. You could do anything to just make sure that that gets out of there. So if we run it now it actually does print this because it eventually does exit that while loop. Okay, so this is what we call an infinite loop. An infinite loop means that you're just stuck in this loop. Your program will never exit, it will never continue running because you're just stuck there forever. So basically what happens is you have this while statement that has true, oh my gosh, true, and then this will just be true forever. Basically your condition is just true forever and then it just gets stuck. So it's still true, and then this will never print. So you want to make sure that the condition that you're checking will include a variable that changes in that loop over time so that it eventually evaluates to false. And then you can exit your while loop and then your program will be fine. It'll still continue to work and it's all good. Yeah? Okay, cool. So if we look back at our example, for a password, things to keep in mind this variable has to exist before the while loop so that you have some data that's being stored that you can change, right? That's the power of variables, right? You have this data, you're storing it, and then you can manipulate it. So this is really important. We need a variable that's stored and assigned and declared before the while loop. And then we have a condition for our while loop, and that variable will change in the while loop so that eventually it evaluates to false. Make sense? So again, you need a variable before your loop. This condition will depend on this variable. And then because it's a variable, the power of using variables is to be able to change that value. That's why it's important to then be able to change it inside your while loop so that eventually this condition evaluates to false, and then we can exit and get out of it, exit that while loop, and then keep on running the program as you want it to. Make sense? So again, while loops too, you want to use them because it allows you to repeat things if you need to. Okay, let's do a little exercise. So if you go to the Wordle Colab, let's think about where we need a while loop. So what part of the game should we be repeating so that we don't need to continue to write the same line of code over and over again, because we need to just repeat it, and we can do that with the while loop. What part? Yeah. Asking the user for a guess, right? We have to do that multiple times and then show the output too. So we can use a while loop to keep asking the user to make a guess. And then what condition needs to be met to stop the while loop? In other words, we keep asking the user to make a guess until what condition? Yeah. You reach 6, right? Or what was the other thing?
When you guess is correct.
Yeah. When you get the right answer, right? So the user guessed the correct word. That's when you know the game's over because the user's already won. Or the user has used all 6 tries. They've lost the game in that case. So keeping this in mind, can we write that while loop? Write that while loop for the game and work together and do it. Yeah, Donovan. Are you good? Okay, how's it going? It's going? Okay. As always, feel free to work with each other or talk to each other. Yeah, Megan. Do you want me to come up there? I'm going this way. Yeah, good question. Maybe I should tell everyone to do that. I don't know. I'll figure it out. I'll figure it out. I know this problem's a little like open-ended. You might be like thinking about more aspects of the game, but just focus on the while loop, if that makes sense. Yeah? Okay. Kind of an open-ended problem, but I'll give you like 1 more minute. Okay. Okay, how's everyone doing? Good? Should we talk about it? You want 1 more minute? I see you all are still thinking and working. Ooh. Okay. Okay, 1 more minute, yeah? Okay, should I go through how I thought about it, or does someone want to walk me through what you all think? Or you want to shout out stuff? Thoughts? What are you all thinking? Okay, let me walk through it. Okay, so how I was thinking about this is I have my while loop and I have a condition that depends on some variable that stores my guess and some variable that stores the answer so I could check if they're equal or not. And then also the number of attempts I've tried, right? So I have while and then the condition that I have that's anding to. While my guess is not equal to answer and I'm still at less than 6 guesses, what am I going to do? I'm going to keep asking the user for a guess because the game's not over yet. It's only over once one of those or both of those conditions are met. Either they've gotten the answer right or they've already gotten 6 tries. So what do I need to do? Remember, I need to update my attempts variable. I probably need to update my guess variable too to eventually make that condition false. So in this case, attempts plus equals 1. The syntax is just the same way as writing attempts equals attempts plus 1, just shorthand. We'll talk about this later probably, but yeah, attempts plus equals 1. And then this was like the open-ended, I don't want you to get into it yet, but we show the output for how close the guess was, right? Every time we played that game, we saw there was this letter that was green, this letter is red, this letter is yellow. All that stuff we're going to build out later, but for now, this is the base of the while loop. And then after the while loop, we add the logic that we were working on last time, which was telling us if the user won or lost. Because this is basically the skeleton of the entire game, is this while loop, right? So if we were to do it all and put it all together, we have our, let's say, answers hard-coded to Colab. And then we have our guess and attempts. Remember these variables that we need to update every time so that eventually that while condition is false. We put our while loop that we just saw here. And then once that condition is false, the game is over, right? We all understand that. The game is over because either they've gotten the right answer or they've used too many tries and they've lost. So then we put this if statement that we already wrote together, right? And then that's the game. So if we were to try it right now and see what it kind of looks like, I have it here. Oops. So if I were to run this, it's still booting up. Okay, so let's say, remember our answer is Colab, it's hard-coded, right? Up here, just to test things out. So basically, I could just keep guessing. Let's pretend I'm typing in 5-letter words. And I type these 5-letter words, right? I'm almost at my end guess. And then I'm done, and it looks like, oh, you lost, the answer is Colab, right? Another edge case I would want to test is if I actually guessed Colab. Does that tell me it's right? And yeah, it says I took 1 guess. Let's try to maybe see if I do it in 2, what happens. So yeah, that took 2 guesses, right? So this is basically the entire game already, right? Except the only thing that's missing is maybe setting that answer word to be a random word, which we'll do soon. Or this output where we're showing all the different letters and the corresponding like letters or colors or symbols, whatever, to show how close that guess was. Yeah? So you've already really built out the skeleton of this entire game by just writing this while loop. And then this if statement that tells you if you've won or lost. Yeah? Okay. That is basically it. So let's tie it all together. So while loops, what are they? Just a control structure that runs a block of code repeatedly until a certain condition is no longer met. So while some condition is true, we keep doing this code and we'll keep checking if that condition is true to keep running that code. And eventually we update those variables that the condition depends on that will evaluate to false. And then we exit the while loop and continue with our program. So why are they important? Well, we can write this code once and repeat it multiple times, so we don't need to duplicate it. We don't need to copy and paste the same code over and over again. We can just have our computer program know that we want to run and execute this code over and over again. And therefore, we don't need to write like 5 if statements or 6 if statements in our Wordle game case. Make sense? Okay. Any questions on this? Anything at all? How was the exercise? The while loop, was it good? It made sense? Yeah? Okay. So today, attendance, feedback. Fill out the form. It's on the course website, also at this link. If you're already on the slides, you can click on the link in the slides. and spend the next few minutes filling it out. And then we'll go over reminders, and then we have a little surprise at the end. But I'll give you like 2 minutes. I'm sure you've all seen the form already. Yeah. The form is on the course website. Right here.
Okay.
And then click on the link. And you all should be able to access it. Aaron, make sure you fill out this form. Oops, sorry. Okay. Okay, as you're filling it out, I'll give you all reminders. So homework 1 due tonight, 11:59 p.m. Questions as always, come, ask, email me, whatever. Homework 2 has been released. Were you able to access it? I forgot to tell you all. I didn't release an announcement, but I'm sure you get the hang of it. Next Wednesday is due. It will cover conditionals and inputs and outputs, stuff we've been talking about for a while. And reminder quiz 2 is this Friday. So first 15 minutes of class, bring your laptops. I will bring my extra one just in case someone needs it. And cover topics are variables, conditionals, input and output. Remember, not file inputs. We're not testing that. And then project 1, it's released. It's building the game Blackjack. So you will have 3 tasks where you write conditional statements, and that's due this Sunday. And then last reminder, I think it's my last reminder, Googler TAs are here to help out. So if you want to book office hours with them, you can do that. You can literally ask them for anything. So if you want to ask them about homework or lab or the project, like that's totally fine. Anything you really want to use that time for, feel free to do that. And just know that those resources exist. So especially if you maybe are feeling like you're falling behind, you want to like review materials, like please use them. They're here and they want to help you. So yeah. Okay, is everyone done filling out the form? Yeah? Okay, Zeal is gonna come up and show you all an application of computer science to physics. You're still filling out the form? Okay, well Zeal's gonna fill out this form. I'll pull up his collab thing. Okay, yeah, but Zeal's working on this really cool project. He showed it to me and I was like, do you want to present about it in class? Talk about it. If any of you have anything you want to talk about, I'm happy to give you 5 minutes every once in a while for one class to talk about something. Manoj, I know you're working on a really cool project. You can come and talk about it too. So yeah, I really want this class to be for you all. And I really want you all to see cool applications of it. So yeah, Zeal, come on up. And if you want to like edit this or like make the window smaller, bigger, just let me know.
Big class.
No, it's not. You're fine.
Good morning, everybody. Hello. So how many of you here hate physics?
Yeah.
Thank you for being honest. How many of you like physics? Okay. Wow. I've seen some people not raising their hands, so it's fine. But in secondary school, actually, there are some concepts that were being introduced to. Just, you know, this kind of thing where the teacher will just briefly say something, but it's like you have interest in it, but like nobody understands. So it's like he just gives up on the class, and he's like, it's not for your level or it's not for your age. I'm sure you guys have heard something like that before. So in secondary school, for me, I was really interested in physics. So our teacher, he came up, a physics teacher, and he mentioned something about a double slit experiment. The topic doesn't really matter, but it has to do with it's something in physics called wave-particle duality. So it's like when he mentioned it, he tried to explain it, but everybody was like staring at him. So he just gave up on us and said it's not for your level, that kind of thing. So I just I found a way to interactively describe that stuff using programming. It's not big stuff actually. It's really small. I'm just saying big words. It's sounding big, but it's pretty interesting. And I thought to really discuss it with you guys because it just shows an application of what we're actually doing in class. Because sometimes I know like when I was trying to like get this stuff, it seemed overwhelming and like why am I learning this kind of? But I think that programming is a really cool superpower because you can apply it to anything you're really interested in. So I'll stop talking now. and I'll just go through it. So this, do I use the screen?
It's inverted.
I mean,
Oh, it's not touchscreen.
like how do I? Oh, okay. Yeah. So, okay, give me a second. Okay. So, basically, you don't have to understand anything here again. But really, what I just wanted to show you guys is how there's lots of if and else statements here. If you can see them clearly, if else, a lot of them, and just kind of understanding the code. But I'll go to the really cool parts to skip the boring parts and then come back to really explain. I'm having a problem with this. Explain this. Okay, yeah. So this right here is basically the experiment. So the experiment is when you shoot a lot of, just imagine like you throw a lot of pebbles through something, through a space, and these are the two spaces you threw the electrons through. These two, you can see them, this greenish bluish stuff here. So how do they appear when they land? Like when the electrons when the pebbles pass through this, how do they appear on the other side? According to waves. Oh my god. Oh my. Oh my.
What are you trying to do?
Yeah, I'm just trying to scroll. Okay, yeah.
Okay.
So this is kind of like how they appear on the other end. But really what I wanted to show you guys is, wow, I should have practiced using the screen before. Yeah. So really what I wanted to show you guys is this part where, oh, I have to run everything again. I am so sorry. This is not how this was supposed to play out.
Just run it.
Okay.
It might take a while. Just run anyway.
There'll be some errors because I didn't run the earlier ones. Okay, perfect. So, yeah, this is like a use of the input statements we've been seeing here. So it's like, what is the slit distance of instance A? So basically, what I'm just trying to show is as the slits increase, as they are being spaced, the pattern that's formed on the other side is also changing, kind of, if you get what I mean. You don't have to get what I mean. But yeah, so for this, they actually fixed values of this. So the first one is supposed to be 5. The second one is instance B is supposed to be 5. Instance A is supposed to be 5. Instance B is supposed to be 10. And instance C is supposed to be 20. So quickly, I will just so this is 5. Now what's the next one? 10, right? 10, then 20. So, oops. Yeah. So we can see that yeah. So if that's the case, it just shows that the simulator works. But in an event where you don't put in the right values, again, like with the if statements, that's really what I just wanted to show. An if statement has been written to kind of, so assuming it's the instance A is supposed to be 5, but let's say I put 4, which is wrong, and instance B is supposed to be 10, but I put 6, and instance C is supposed to be 20, but I put 15. These 3 are wrong, so it's just trying to show that like my simulator doesn't, like the simulator doesn't work, kind of. So if you put this in, and you go down a bit. Okay, yeah, so that's why some people like physics. So you could just stick to biology if it doesn't make sense. So yeah, and this table is really just is really trying to show if the values correlate, because what this is trying to do is if you actually solve this, yeah.
I'm a physics major.
Okay.
What's your name? Do you mind if I email you?
Sure.
What's your name, Leslie?
Okay, thank you. Hey Sarah. Yeah.
It's,
Did I tell you my?
I can email you.
Yeah, okay.
Yeah, I'll email you each other's emails.
Okay.
I'll create an intro email.
So basically, why I'm not trying to get too deep in this, but like why you're seeing this mathematical here is because there are actually some formulas that I used to get these values, 10, 20, and 40. And the simulator is supposed to give me corresponding values of 10, 20, and 40 under that experimental bracket, that column. But once it doesn't give me that, it means that the mathematical answers I'm getting are not the same with the answers that the simulator is getting. And so it replies, no, for these 3. I don't know if that makes sense. But this is just a lot of like if and else statements to just kind of show how if the answer is correct, if the answers correlate, basically it gives yes, but if they don't correlate, it gives no. Yeah. So yeah, I could not find a better color. I actually hate purple, but this was the only background that there was.
Yeah, I think
So,
it's
yeah.
super cool that Zeal's also like importing all these libraries, doing all of these functions and calculations, and like creating these images, which is such a cool thing that you can do with these like Python notebooks that all of you could also really easily do. And we'll learn about this too, like how to use different libraries and stuff. So, but yeah, great job.
Thank you.
Thank you. Do you have any last thoughts? Any last thoughts you wanted to say? No, that was it.
Sorry.
Any more thoughts, or that was it?
Yeah. I wanted to say one more thing.
Okay, yeah. Sorry,
What,
I didn't
just-
mean to interrupt you.
Just one more thing. So
Hit cancel. Cancel.
I'm tapping. I'm really
Oh yeah,
tapping.
it's a trackpad. It's a little different, yeah.
Yeah. So what I wanted to say. This block of code, blah blah blah. Yeah. It was really about just importing this. So I wanted to say that I had some like a brief difficulty I had during this was like importing. So to get these figures and these diagrams and everything, you have to import some libraries that have some like inbuilt functions. So if you don't do that well, or if you import a wrong version, you can see lots of errors and get really frustrated. So import the right versions and right libraries.
Yeah, we'll talk about that next week too. So, good job! Thank you! That's Vivian, by the way. Yeah.